Okay, so this last section on this, okay, is 7.7, and it's about graphing again, okay? So 7.7 is writing and applying exponential and power functions. Okay, 7.7, we're gonna write and apply exponential and power functions. So we're going to create equations off of graphs or off of information they give us. So we're not actually graphing exponential function on this one, we're taking an exponential function and creating an equation. Okay, so your standard form of an exponential equation is y equals a times b to the x power, yes? Okay, y times my constant, b to whatever power I have. So, let's say it says write an exponential function y equals a b to the x whose graph passes through 112, okay, and 3108. Okay, so it passes through those 2 points. Does that make sense? We are going to figure out how to solve this. We have to create 2 equations, okay? What is 1 and 12 represent here? What are those?
X and Y.
X and Y. Is there an X and Y in this equation?
Yes.
Okay, so I'm going to plug this in for X and Y, and I'm going to plug this in for X and Y. I'm going to create 2 equations. Okay, so my first equation is 12 equals a times b to the first, okay? And my second equation is 108 equals a times b cubed. Yes? Does that make sense? Okay, we are going to take one of these equations and we're going to solve it for a, so that we can plug it into the other equation for a, okay? So we're going to take one of these equations. My suggestion is take this equation and solve it for a. Because how do you solve for a here? You would get 12 over b to the first equals a, yes?
Yeah.
Okay, now I'm going to take this and I'm going to plug it in for a here. 108 equals 12 over b times b cubed, yes? This has a first with it, yes? If I have a power divided by a power, what do you do? Subtract. So you get 108 equals 12b squared.
And then you
Divide by
well,
12, and b squared equals, what's
I
100?
think 9.
9? Yes, 9. Now, what's the square root of 9?
3.
Yes, so you get 3 equals b, correct? Okay, now what do you think I'm going to do with that?
Plug it back.
If I plug it into this, I can get what a is, okay? So I take this right here, and I plug it back in up here. So you have 12 over 3 equals a. So what does a equal?
4.
4. So then my equation is y equals 4 times 3 to the x power. Okay,
So it's kind of like a, is it kind of like
it's like substitution, yes.
Mm.
You are correct. Yeah, cool, you're right, but it's just with exponents. Okay?
yeah, it doesn't seem hard, it just takes a long time.
It does. It doesn't, it's not hard. It does take a long time. You are correct about that. Okay? Now, let's say they give us data. Okay? 112, 216, 325, 436, 550, 667, and 796. Okay? And they tell us that X represents years. Okay? And Y represents number of scooters. Okay, and here's what it says, it's a word problem. It says, a store sells motor scooters. The table shows the number Y of scooters sold during the X year that the store has open, okay? And then it says, draw a scatter plot of the data, okay, X, L, and Y. Here's the deal, when they want us to draw a scatter plot, okay, okay, here's what they said in the directions. Draw a scatter plot of the data X, L, and Y. What do you think that means I'm doing?
Using natural log.
Using natural log with whatever these numbers are,
Yes.
okay? And it's going to change it for us into decimals so that I get a shorter graph, so that I can translate it a little bit more, better, okay? Is an exponential model a good fit for this data? Okay? So we're gonna do this first, and then we're gonna decide if it's a good fit. And then there's one more question. So when you are doing all of your scatter plots tonight, okay, you're going to have to graph it as X, L, and Y, okay? So we need to change this data. So if I put in, I have 2, 3, 4, 5, 6, 7, right? So if I put in L in 12, what do you get out? Just round to one decimal.
2.5.
2.5, so this is X, this is L N Y, okay, I'm labeling it that way. If I put in L N 16, what do you get?
2.8.
Okay, L N 25. Should be 3.2, L N 36, should be 3.6. LN 50 should be 3.9, LN 67 should be 4.2, and LN 96 should be 4.6. Okay, do you see why I did this? If you change it to natural log, now I have numbers that are easier to graph that are closer together. Does that make sense? Instead of making a graph that goes from 12 to 96. Okay, that's why they're doing this, because it's probably an exponential model. If you change it into natural log of whatever it is, because it's exponential, you'll get smaller numbers to graph and scatter plot, okay? So if I go to scatter plot this, you're gonna have 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5. So 1 is at 2.5. One is at 2.5, 2 is at 2.8, 3 is at 3.2, 3.6, 3.9, 4.2, and 4.6, right? So like this. So your graph is going like that a little bit, okay? It's rising like that. There's your scatter plot, okay? Would this be a good exponential model? The answer would be yes, okay? So now we have to find an exponential model for the original data, okay? For the original data, not for the data we used here to graph, for the original data. What is our exponential model usually? Y equals A, B to the X. Okay, Y equals A, B to the X. Okay? By choosing 2 points on the line, okay, we can use those points to solve. Now, here's the deal. The points on the line, we did what to?
Natural log.
Natural log. So when you set this up, you have to use 2 points on the line to solve. When I use 2 points on this line, okay, think about a linear model, because this looks like a line, yes? Okay. What is the equation to solve for a line? How do you, when you have 2 points? What do you? Y equals mx plus b. Okay, what's the m?
Is
So we have to find slope first, and then we have to put it into point slope form to solve, okay? How do you find slope? You just have to choose 2 points, right?
Yeah.
If I were you, I would choose the first point and then just pick a point that's a couple away from it or something, okay? So I'm gonna choose this and this, it doesn't matter what 2 points. I'm going to find my slope. So 3.6 minus 2.5 over 4 minus 1, yeah? 3.6 minus 2.5 gives me 1.1, yeah? And then 4 minus 1 is negative 3. What's 1.1 divided by negative 3? Oh wait, did I do that in the right order? Yeah. Okay, so you should get something like 0.36, something around those lines, yes?
Where you get the
Change in
negative-
y over change in x.
Where you get the negative from?
You don't. It's just, sorry, I wrote it wrong. So you should get 0.37, something like that, okay? So you get 0.37, that's my slope. Now, I choose one of these 2 points for my point slope. I'm just gonna choose this one because it's easy, okay? Here's the deal though, with this point slope, this is not just y, it's what?
Natural log.
Okay, so instead of setting up y minus y1 equals m times x minus x1, because that's point slope form, yes?
Yeah.
Okay, this is gonna say natural log of y. Okay, I have to exchange that because it's not a y anymore, it's the natural log. Now, I plug in my y1, which is 2.5. I plug in my slope, which is 0.37. And I plug in my x, which is 1. And you're gonna solve from there, which means you have to have your calculator do this because you have natural log involved, okay? So, you get natural log y minus 2.5 equals 0.37 minus 0.37, right? This should be 0.37x. So you add 2.5 to both sides like you normally would. Nothing changes there, and you have natural log of y equals 0.37x plus what is 2.5 minus 0.37. $2.13, okay? Now, the only downfall is, what do I still have here?
Natural log.
How do you get rid of natural log? E. So e to the natural log of y equals e, remember what you do to one side, you have to do to the other, yes? 0.37x plus 2.13. This cancels, right? Y equals, okay? And the way the book wants you to write this out is they want you to separate it, because here's the deal. If you have e to the 2.13 plus e to the 0.37x, you can do this in your calculator and get a number here, okay? So y equals whatever e to the 2.13 is, 8.4? 8.41 plus e to the 0.37x. Now look at this. That is in a linear model of an exponential
You have
form.
to show all of that?
You have to show all of that.
Ah,
You have to show all of that. We are not doing the third example in this book, okay? Because it is with your graphing calculator, you cannot do it,
Whatever.
yes.
okay? We're gonna do one more, example, and we're not doing the fifth one either, because that's graphing calculator, and we're not gonna go that far, okay? So we're gonna do one more. This is just too much. Now, this was exponential form, yes?
Yeah.
Okay, now we're gonna do power form. Okay, power form looks like this. Exponential is where the exponent is the x. Okay, power form, the exponent is the b. Okay, so power form looks like y equals a times x to the b. Okay, this is exponential. which makes sense, your x is in the exponent spot. Power form, the x is not in the power spot, okay? So if you have something that passes through 3, 2, okay, and through 6, 9, okay? How do you think I'm going to do that? What do you think I need to set up? What am I gonna do with those 2 points? It's basically the same as this exponential form, except for my x is not in the same spot. So you have to set up 2 equations,
Yeah.
and then you're gonna have to solve. 3 goes in the x, 2 goes in the y. 2 equals a times 3 to the b, okay? My other equation would be 9 equals y, 9 is y, a times 6 to the b. Do you see those 2 equations? Okay? Now, what do you think we need to do to one of the equations?
Do 2 over
Uh-huh.
B,
2 over 3b equals a. And then what can I do with this?
plug it into the A.
Plug it into the a. 9 equals 2 over 3b, right? Times 6 to the b. Okay? What happens when you have a power over a power?
Subtract.
You subtract, right, or whatever. What happens if the powers are the same? Like right here, b and b is the same, right?
Then can't you simplify that?
You can. So what's 6 divided by 3?
2.
So I get 2 times 2 to the b, right? Okay. Now what do I do with that 2 here?
Divided?
Divided. What's 9 divided by 2?
4.5.
So 4.5 equals 2 to the b. Okay, that's in my power spot, the b is, correct? So how can I get rid of that?
You have to square root it.
Mm-mm. The power is not a number. How can I get rid of this so that says b equals? You're going to have to use log. So you're gonna have to go log base 2 of 2b equals log base 2 of 4.5. These cancel. And it gives you log base 2 of 4.5 equals b. Now, how can you solve for b? Starts with a C, blank of blank,
Change the base.
change of base. So, I'm gonna draw an arrow up here. So you're gonna say log 4.5 over log 2 equals b. What's log 4.5 divided by log 2? 2.1, or 2.2, we're just gonna round to 2.2. So b equals 2.2. What do you think I do with this now?
Plug it
Okay.
in.
Let's plug it into there. So I can solve for a. 2 over 3 to the 2.2 equals a. Okay, so do 2 divided by 3 to the 2.2, and you should get 0.18, if I round to 2 decimals, 0.18, okay? So a equals 0.18. Now, I can take that information, I can plug both of those into this equation right here. Y equals 0.18 x to the 2.2. There's my equation. Okay? Everything you are doing tonight, you have done everything that leads up to this. We're just literally combining everything. Okay, cool.
So, whenever we have that problem with the y equals ax
Uh-huh.
to the b, it's always going to be the log. That we're going to use log in that.
Yes, anytime the b is in the exponent, you will use log. So anytime it is a power function, you use log. When it's already an exponential function, you just do math, okay? This is just division and multiplication. Anytime the power is the b, you use log, period, okay? And then anytime that you use natural log to do your data, you will have natural log in your equation, okay, for point slope.
In our test, how many of those do we have?
Not a ton,
Okay.
okay.
Why does it go
Yes.
from